Hey, it's Mr. Estrada here, and for this video, our learning target says I can prove two triangles congruent, angle side angle, and angle angle side. So in this video, we're going to prove two triangles congruent. We're going to do two examples, one using the ASA method and the other one the AAS method. So here is our first example. We are given that triangle ABC is a triangle. We are also given that BD bisects angle ABC and that BD is perpendicular to AC. And we are to prove that triangle ABD is congruent to triangle CBD. All right, now look, what I've been saying all along with these proofs, it's not what you know, it's what you can prove, right? It's not what you know or what you can see with your eyes. So, for example, somebody may be thinking, well, to me it looks like AB is congruent to BC. Well, can you prove that based on the given information or based on what you can deduce from the given information? And the answer is no, you cannot prove that right now. So let's use the given information to deduce appropriate conclusions. So it says that BD bisects angle ABC. What do we deduce from that? What do we get from that? Well, we have an angle bisector, and an angle bisector is going to create two congruent angles. It's going to split angle B into two congruent angles. So we can deduce that this angle here is congruent to this angle here. So you see what I did there? I use what's given to draw a conclusion. What else do I know? I know that BD is perpendicular to AC. So this says BD is perpendicular to AC. What do I deduce from that? Well, perpendicular lines make 90-degree angles. So I deduce that this is 90 degrees and this angle is also 90 degrees. Then, from looking at the diagram, I can also deduce that line BD is being shared by both triangles, so I'm going to have a reflexive property here. Now you can see from here that you're going to have angle side angle congruent to angle side angle. So that's how we're going to write our proof. We're going to use that. So let's actually write our proof. So you see what I did there? I always use what's given to draw conclusions, okay? Always use what's given to draw your conclusions. Begin by labeling your diagram, and then you want to write your proof. That's how I do it. That's what's worked for me, and it seems to work for a lot of people. So the first statement, of course, we're just gonna write down the given information, and let me just go ahead and actually just type this up. So we've got triangle ABC, BD bisects angle ABC, and we also have BD perpendicular to AC. And let me just get my symbols in there. So this says triangle ABC, comma, BD bisects angle ABC, and BD is perpendicular to AC. And then all this, of course, is given to us. And I can just abbreviate given. All right, then what else did we say? Well, we said immediately that angle CBD is congruent to angle ABD. Let's get rid of that. That's not what I want. So let me go ahead and write that. So we said angle CBD. So angle CBD is congruent to angle ABD. And why did we say that? What was our reason for saying that? Well, it was because of the angle bisector, right? So you can just write definition of a bisector, or you could even write BD bisects angle ABC. I'll just write definition of a bisector. Definition of a bisector. That's what a bisector does, right? It makes two congruent angles. Okay, then what else did we say? Well, we said angle CDB is 90 degrees. And we also said angle ADB is 90 degrees. So angle ADB is 90 degrees. And why did we say they are both 90 degrees? Because of the perpendicular lines, right? The perpendicular lines make 90-degree angles, so I can just write definition of perpendicular lines. So definition of perpendicular lines. Okay, next. I can now say that angle CDB is congruent to angle ADB. So that's congruent to angle ADB. And why is that? Well, because all right angles are congruent, right? All right angles are congruent. And I'll just use the symbol for congruent. Then what else did we say? We said that we have a reflexive property, so BD is congruent to BD. It's a shared side. So BD is congruent to BD, and that's because of the reflexive property. And then finally we were able, based on all this information here, we were able to say that triangle ABD is congruent to triangle CBD, and we said because of the angle side angle being congruent to angle side angle. So there's our proof. All right, so let's follow the argumentation of our proof here. We're saying that, and let's begin by looking at the conclusion and work our way back. So we're saying that the two triangles are congruent because of the angle side angle congruent to angle side angle postulate. So that means that I have to demonstrate in my proof that you have an angle congruent to an angle, a side congruent to a side, and an angle congruent to an angle. And of course, since it's ASA, the side has to be included, meaning it has to be between the two angles. So did I show that in my proof? I did. I showed right here angle congruent to an angle in line 2. And in line 4, I also showed an angle congruent to an angle. And in line 5, I showed the included side congruent to the included side. So you could see how in my proof, I sort of make the argument and then I end with the conclusion, with what I'm trying to prove. So example 2 is a fill-in-the-blank proof, and sometimes in the Regents you get lucky and you get these fill-in-the-blank proofs. So we're going to still use the same procedure I've been using. We're going to use the given information and what we can deduce from the given information to label the diagram, and then we're going to formulate our proof. So just remember that, okay? You always want to begin by using the given information to make certain deductions to label the diagram. So it says AFCD is given. Okay, that just means AFCD is a line. Then we are given that AB is perpendicular to BC, and there is something we can deduce from that. If AB is perpendicular to BC, then that means I need to have a 90-degree angle somewhere. You got to have 90-degree angles somewhere because perpendicular lines make 90-degree angles, and you'll have the 90-degree angle right over here at the intersection of the perpendicular lines. Then you can see here, DE and EF are also perpendicular, so you'll have a 90-degree angle at the intersection. So that's 90 degrees also. Then it says BC is parallel to EF. Now, listen closely. BC parallel to EF does not mean that BC is congruent to FE. That is wrong. Parallel does not mean congruent. Parallel means parallel. And I'm going to just be very blunt with you. Usually when they give you a pair of parallel lines in these proofs, they want you to look for alternate interior angles or alternate exterior. But most of the time it's alternate interior. So with that being said, we know that BC is parallel to FE. So if I form my Z, I know that I'm going to have alternate interior angles here and here. So let me go ahead and label those bad boys. So here you have alternate interior angles that are congruent to each other because BC is parallel to FE. So you got alternate interior angles there. Then we are just told explicitly that AB is parallel to DE. So, you know, they just tell us flat out AB is congruent to DE. And now you can see from this that you have angle side. So we got angle side congruent to angle side. So we know our proof will end that way, right? It will end with us saying angle side congruent to angle side. That's how we're going to prove that these two triangles are congruent to each other. So let's fill in some blanks. So they filled in the givens, these givens first, and then they said angle B and angle E are right angles. Now, why are they right angles? Do you remember why they were right angles? Because of the perpendicular line. So we can just write definition of perpendicular lines. So let me go ahead and write that. Definition of perpendicular lines. Definition of perpendicular lines. Okay, next, why did we say, well, you know what? Before I fill in the blank for number 6, let me just follow their argument here because it's good to see. They said angle B is congruent to angle E. And do you remember why they're congruent? Because all right angles are congruent, right? If they both measure 90 degrees, then obviously they are congruent. Then they put the given here, the BC is parallel to EF, given right over here. EF, FE, same thing. Then they said angle BCA is congruent to angle EFD. So they're using those parallel lines, right, to say that these two angles are congruent because parallel lines make what? Alternate interior angles. So that's the reason for number 6. Alternate interior angles. All right. So there's our proof for example 2. And that brings us to the conclusion of our video, and I hope this helps. Take care.